Hello everyone. Now, today we are going to discuss General Organic Chemistry (GOC). Why General Organic Chemistry is that much important? Why it holds that much weightage throughout the preparation phase of your IIT JEE Advanced or IIT JEE Mains? We can call it JEE Mains only because it is just a basic entry level exam for your IITs. And the next one, which is the advanced exam, and what are the question level? Although the 2026 paper was moderate, but that in the previous years they can trouble you with a good level of organic question. And then finally for other examinations like NEET, BITSAT, and like this, whatever all pre-medical and pre-engineering exams hold a good amount of GOC weightage. But the application of GOC in reality will be more useful in the first three exams. The remaining also will have. I'm not saying that they will not have the questions, but they will have. So where does the GOC one revolves around? The GOC revolves around few elements who form the organic compounds. So first thing I should know the electronegativity of these elements and electronic configuration of these elements. So this electronegativity values according to Pauling scale I should know along with few more elements like chlorine. Okay, so fluorine is the highest electronegative element which is 4.0 as per Pauling scale. Now let's see outer electronic configuration 2s2 2p2. So dear, I am writing the ground state configuration, not the excited state one. Here this is 2s2, 2p3, 2s2, 2p4 and 2s2, 2p5. So you can see how the number of valence electrons has been increasing when we jump from carbon to nitrogen, nitrogen to oxygen and oxygen to fluorine. So further, what is the weightage? What is the weightage of this GOC1 topic? Actually, GOC1 has a lot of subtopics, small topics in it. But let's focus on the main topics which are regularly asked, and let's go to see the weightage. So if I go to the next slide and see the topics which we have and how many questions we should expect from the general organic chemistry, and mind you, this is for our NEET and mains. In advanced paper, you don't get a exact direct question from GOC, but you will have applications. So these 3 or 4 bits, whatever, on GOC will be directly from your notes or directly from your preparation material, and that is in your NEET paper and mains paper. In advanced paper, you get applications. You get applications. So before going to GOC, we should know few basics. And I know that whoever has started organic chemistry, they know these basics like hybridization, sp3, sp2, and sp. So whenever a carbon has two sigma bonds, it contains which hybridization? Sp hybridization. And the molecule is linear. Molecule is linear. What would be the bond angle of this sp hybridization? That is 180 degrees. Let's see, what about sp2 hybridization? My dear students, sp2 hybridization is nothing but trigonal planar. Do you remember how I have drawn this? And what would be the bond angle in this sp2 hybridization? That is 120 degrees. Now, this is not a tetrahedral. Whatever we have drawn here, this is not a tetrahedral. Sir, how to draw the tetrahedral structure? Now, here we have two bonds and two more bonds here. One bond is going out of the plane and another bond is going into the plane. So, here you see this bond is called as wedge bond. This bond is called as wedge bond, and this bond is called as dash bond. So do you remember in a regular tetrahedron, what would be the bond angle? Now 109 degrees to 8 minutes. Okay. What does this wedge bond and dash bond means? Now they are not in the plane, they are non-planar bonds, and dash bond suggests that it is out of the plane, whereas the wedge bond suggests it is into the plane. It is into the plane of the paper, and this is out of the plane of the paper. As we are watching this on a device, so it is into the plane of the device and out of the plane of the device. Now let's see what are the main basic effects or the electronic effects which follows. Sir, does BOC ends here basic organic chemistry? No. Basic organic chemistry has a lot of other parts. So we will bring a like separate thing for basic organic chemistry. Now the need of the hour is general organic chemistry, where we face a lot of problems, and when we start our revision for IIT Advanced in upcoming months, these topics are very useful in order to grab the concepts and mechanisms in our organic chemistry. Even a simple question like acidic strength or basic strength or stability of the carbocation or carbanion will use all these effects. So what do we mean by inductive effect? What do we mean by inductive effect? Now inductive effect is a permanent displacement of sigma electrons. So remember, permanent displacement of sigma electrons. So if the sigma electrons are pushed towards the carbon atom or towards the carbon chain, that is called plus I. Plus I means donor, electron donating effect, EWG, electron donating group. And if the electron density is pulled away pulled away from the carbon chain, that is called withdrawing group or EWG. So now, without using a lot of brain, we just have to know what are the EWGs and what are the EDG, electron donating groups, as per inductive effect, not per resonance effect. So electron donating group as per inductive effect, as well as electron withdrawing groups as per inductive effect, we have to see. And let's see what are the electron donating groups. Before going to that, let me tell you that inductive effect is a permanent effect. You know that permanent effect in the first slide we have discussed. So now, as it is a permanent effect, up to which number of carbon it works. So if a group is attached here, G, group for atom, any one of them is attached. So highest will be here, del positive 1, and then del positive 2, then del positive 3. Sir, how you know it is del positive? Now, if this group is a withdrawing group, EWG, if it is a donating group, you will get del negative. So anyway, after third carbon, this inductive effect is very less. After third carbon, inductive effect is very less even to consider. So here you see this is carbon 1 directly attached to group carbon 2 and carbon 3. So inductive effect works up to carbon number 3, and the displacement of the sigma electrons towards this group. These two electrons will displace towards this group. It is a withdrawing group, right? So if it is a donating group, the arrows will go reverse. So if this displacement happens, the displacement will be maximum here. Delta x1 will be maximum compared to displacement in the second carbon, delta x2, and compared to displacement in the third carbon. After third carbon, the displacements are very less. So we don't consider the value of the displacements there. And as per the like strength, who is pulling the electron more, we have decided that what are the electron withdrawing groups. But here first let me tell you the electron donating groups as per inductive effect. Who will give more amount of electrons, or who will push more amount of sigma electron density to the carbon chain, to the parent chain. So here we have CH2 minus. The negatively charged groups will push more amount of electron density compared to the neutral groups. Negatively charged groups will push more amount of electron density compared to the neutral groups. So here we have carboxylate, here we have oxide, here we have amide, and here like NH minus, not amide, and here we have CH2 minus, carbon ion, and then we have the groups, bulky groups, 3 degree, 2 degree, and then 1 degree, and then methyl. So these carbon containing groups are also donors, and as per inductive, 3 degree or 2 degree and 1 degree is the order. Then we have the reference hydrogen. If we take the isotopes of hydrogen, deuterium and tritium, they will have more inductive effect than hydrogen. Similarly, when we come to withdrawing groups, there also we have to see few more things regarding withdrawing effect. So the reference of inductive effect is hydrogen. So if I have a carbon which is attached to hydrogen, I'll tell the inductive effect is 0. Here this is the standard case, and there is no inductive effect, neither pulling or pushing of the electron, and the sigma electrons are present at the exact center of the covalent bond. So we consider this position of the sigma bonds, sigma electrons as the exact standard. And then if you attach any of the above groups in this slide, they will push the sigma electrons towards carbon. Okay. And what will happen as a result of that? Now the carbon will gain more electrons and get a del negative. Now what already I told you, now electron withdrawing groups or minus I groups itself having positive will act as electron withdrawing group, or if the element is more electronegative they will act as electron withdrawing group. So itself having positive and more electronegative elements will have withdrawing effect like this. So you see NF3 plus, NR3 plus. Here you can also write NR2, NHR2 plus. Here you can also write NH2R plus, then NH3 plus, then NO2, then CN nitrile, and then COH carboxylic acid, then fluorine, chlorine, bromine, iodine, and then ester COOR. So ester has less withdrawing power than carboxylic acid. The reason we know, and more explanation will come in resonance. Here why OR or OH are, why OR or OH are withdrawing group. My dear students, here due to electronegativity. If you go a little bit forward, you will know that they will show another effect called resonance. So here I am not talking about the resonance donor ability. I am talking about the electron withdrawing effect or electron withdrawing group ability due to inductive. So they are EWG due to high electronegativity and they show inductive effect. Then you remember sp and sp2 carbon are electronegative. So if they are electronegative carbon, they will withdraw the sigma electron density towards themselves. They will attract this sigma electron density towards themselves and they will induce a positive charge on the carbon which is there. So if a EWG is there, the carbon will get a del positive. But if the carbon atom is attached to a EDG electron donating group, the carbon will induce a del negative, my dear students. So this is all about inductive. Inductive के basic points हमको आने चाहिए. And if we know these basic points of inductive, and then one more thing I need to tell you. The other thing is that percentage as character in the hybridization. For example, SP hybridization has 50% S character. Do you agree? 50% P, 50% S. SP2 hybridization has 33% S character. So here percentage S character is proportional to electronegativity of the carbon. And more electronegative carbon, more withdrawing it will be. Now, let's see what are the applications of inductive effect without going into resonance or hyperconjugation, only and only purely based on inductive. So you will find a very rare question only based on inductive, and if you find that, then you have to identify if it is electron withdrawing group or electron donating group, EDG or EWG. And once you find out them, then you have to tell that electron donating group will increase the stability of carbocation, but electron withdrawing group will decrease the stability of carbocation. Similarly, electron withdrawing group will increase the stability of negative charge carbon ion, whereas electron donating group will reduce it. Same with acidic and basic strength. Acidic strength is increased by negative or withdrawing groups, whereas the basic strength is increased by electron donating groups, right? And then what about K and Kb? Now K and Kb are also useful in K and Kb are also useful in checking like who is more acidic, who is less acidic, or who is more basic, who is less basic. K is acid constant, Kb is base constant. So if a acid or if a organic compound has more Ka, that is more acidic. Whereas I see pK is inversely proportional to Ka and inversely proportional to acidic strength. So now you don't worry, this is just a half knowledge. And with this, we cannot solve any question which has resonance or which has hyperconjugation. So finding out a question with only inductive in your advanced paper is very, very, very rare. And in your mains paper also, you may find. So there are few examples. Definitely we'll discuss and we'll continue in the upcoming lecture, right? So what is the other effects which we have to discuss in the next, that is M. What is M? Don't think something else. Okay. So here M for mesomeric. What is the other name of this mesomeric effect? Is resonance, or pi electrons will move. And then what is H and what is I? So today we just got a brief introduction about inductive effect. And inductive effect is the most weakest one out of the three effects we are going to study. Inductive effect is the most weakest one, right? So just know the groups of inductive effect and then wait for the questions to assemble by using all the three effects. And once we start using all the three effects, then it would be fun. Only knowing inductive donors and inductive withdrawing groups are not very much fun. But one thing, they can directly ask the inductive effect orders like mains 24, 25, or in your NEET paper, they have already asked which one will show more inductive effect or which one will show less inductive effect. And there are questions on stability of the carbocations like this: which carbocation is more stable, CT3, CD3, or CH3? Which carbon ion is more stable, CH3, CD3, and CT3? Here you have to solve it by only inductive. So plus psi effect of tritium is greater than deuterium is greater than hydrogen. So plus psi is there means positive charge will be more stable. Plus psi is there means negative charge will be least stable. That's it. So these type of questions will be arrived or derived from the inductive part. So we'll wind up for this lecture and we'll go to the next lecture where we discuss about the next effect called hyperconjugation and followed by resonance. Okay, let me close it.